Okay guys, so in this lesson today, the rocket launch simulation, I'm just going to walk you through a couple of key things here that if you were not here for class, you would have missed. Okay, so starting off on this first slide here, we see that this assignment has 5 different variables that can impact the flight of your rocket. Now, it's important to understand, before I get too far ahead of myself, it's important to understand with this assignment that the purpose of this assignment is not to fly this rocket and accomplish the task, but really the purpose of this assignment is to properly learn how to fill out a data table. Okay, specifically this data table here you can see is what you're going to be filling out and what I'm going to be grading you on. Okay, but going back up here, as I was mentioning, there are 5 different variables that can affect the flight of this rocket. They're the mass, which is how heavy the rocket is, the thrust, or how much fuel it has, time of thrust, how long it takes to burn that fuel, drag, which is friction from the air, and then mass change, because as you burn fuel, the rocket will end up weighing less. So we can account for that there. The purpose of this simulation is to not necessarily launch a rocket as high as possible. You'll see on your copy that's been changed, but your task is to deposit a satellite in orbit around the Earth. You can actually get the rocket to fly too far, and then you won't be able to deposit the satellite. The defining question is, what of these variables will help you most to accomplish that task? So your first step is to fill out this hypothesis right here with what variable or combination of variables you think will help the most. Okay. Now, we need to take a minute and define some terms that we've actually defined before, but we may have forgotten. Okay, so we're starting off with a dependent variable. So if you remember, a dependent variable is the results from your experiment. This is also called the data. Okay, in this experiment, the dependent variable would be how high the rocket flies. Okay. Now, to define what a control variable is and kind of help you do that, I've got a little bit of a demonstration. I'm going to transition this into another video showing that demonstration and talking about the need of having a well-designed experiment, because once we understand that, then the purpose of a control will make more sense.
Okay, to explain the importance of a control variable, we're going to set up an experiment dealing with these pitch pipes, or boom whackers they're often called, and I'm purposefully going to set it up as an incorrect experiment, and I want you guys to try and figure out what is wrong with this experiment. So the way these pipes work is if I take one and I hit it on something, it makes a pitch. Now, I want to know, what can I do to change the pitch from the pipe? And so I have 2 theories. I wonder, okay, maybe if I cover the end or use a pipe of a different length, that will change the pitch. So for my experiment, I've got my original pipe, and I'm going to cover the end, use this pipe, and hey, look at that. We've got a different pitch, so it must be because I covered the end, right? What did I do wrong? Well, if you were paying attention, you notice that I changed 2 different things here. I've changed both the length and I covered the end. So the key with this is that we don't know what caused the change in pitch. Was it a change in pitch because I covered the end? Or was it a change in pitch because I used a longer pipe? Okay, so what we would need to do is test only one variable at a time. There we were testing 2. We want to test one variable. Okay, and that's everything else that we're not testing, we call that a control. So to set this up as a good controlled experiment, we would take the pipe, we do the original, or the control is what we call it. Then we change one variable. Let's try covering the end. Okay, I cover the end, and it changes my pitch. I get a lower pitch there a little bit. Okay? So if I cover the end, we know that we get a lower pitch. So that means that the first time it must have been because of the pipe was covered, right? Well, we still don't know, because I still changed two things. So we still need to do another experiment comparing the normal pipe to a longer pipe. So we take the normal pipe and uncovered, and the other pipe. Once again, uncovered. And we see, hey, this also changes pitch. Okay, so our first example, where we covered the bottom and used a longer pipe, it was actually being affected by both variables, but we didn't know that. Okay, we could have easily assumed it was one variable or another. So that's why it's so important that we only change one variable at a time.
All right, so we should be back from that demo dealing with the pipes and talking about the need of having a controlled experiment. So from that, we should understand that a control is any variable that needs to stay the same. Okay, a control is any variable that needs to stay the same. Okay, so in the pipe example, we could both cover the end of the pipe or change the length of the pipe, but to have a good experiment, we needed to only do one of those at a time, which means the other one needed to be a control variable, or something that didn't change from the control group to the experimental group. So looking at these 5 variables that we mentioned before, mass, thrust, all that, we need to determine at what point would each of those be a control variable. Okay, and if you're thinking ahead, you should realize that all of those at some point should be a control variable, right? So our mass, thrust, time of thrust, drag, and mass change. Okay. Okay, let's review an independent variable. Independent variable, if you guys remember, is the variable changed or manipulated by you, okay, as the scientist. And you're going to be running this simulation 15 times. And over those 15 times, you'll be testing or changing the mass, the thrust time, the drag, and the mass change. Okay, so each of those will end up being used. Okay, now let's test what you've learned here. Should you test multiple variables at the same time? Why or why not? I want you to answer this. Now, I'm going to give you a hint. It's a no, but I'm going to leave it to you guys to explain why not. Okay, and I will be looking at your answers here. Okay, so let's get into this this data table here. So as you can see, I've already set up the control, okay, with the different variables established, but we don't have results. So we need to run through this and run results. Now, for this, I personally prefer to use split screen, okay, because then I can see everything all in one place. So I see that my variables I've set up here are the same as they are here. So I can just hit launch, and then I am going to fast forward through the launch once it allows me to do that, so I don't have to wait as long. Okay, and I see right there that my rocket traveled 5 kilometers. So I'm going to write over here 5 kilometers. Now I want to run an experiment. That's my control. Going to run my first experiment. Let's say I want to test the variable of the thrust time. So I'm going to increase that a little bit. So I need to fill out my data table, okay, with this information here. So my mass is 1200, thrust is 25,000. The time of thrust is now 60. Drag is still off, and mass change is still off. Okay. Then I launch my rocket. Okay. Once again, I'm just going to fast forward. This time I got 42 kilometers. Okay. Now we're going to do another test. This time let's test thrust. Okay, so let's increase thrust. Yeah, that looks good. Okay, so going through, recording all of our data, we've got a mass of 1,200, a thrust of 101,900, time of thrust of 60, drag is off, mass change is off. Now, did I fill everything out correctly? No, the answer is no, I didn't, because my time of thrust over here needs to be compared back to the control. So that needs to be 20, which means over here I need to move this back down to 20, okay? Because we're only testing one variable at a time, it is very important that when running that test, that variable is being compared from here to the control, from here to the control, here to the control, okay? So on and so forth. Okay, that's how we establish that. So let's launch our rocket. Let it fly off. We'll fast forward it a little bit. Okay. All right. And our rocket made it 120 kilometers. Okay. Now I'm going to close this for a second. So going through this, we've now been able to, fill in the first control and then the first two trials, okay? Now you're gonna go through, you're gonna do the rest of these, okay? Once you get down here to the new control right here, okay? At that point, you may want to, or at that point you can change any variables you want. Whatever you think will help in order to get the rocket to be able to deliver its payload, okay? I can speak from my own experience. By changing one variable, you will not succeed. But once again, the purpose of this lesson is not to succeed at the game, but to actually fill out this data table properly, only changing one variable at a time compared to the control, not compared to the previous trial, okay? But once you get to the control, you can change anything you want. You can change the thrust and the thrust time and the mass, and you turn your drag on or off or whatever you want, okay? Then after that, when you're looking at this new 1 and 2 and 3, those are going to be compared back to the new control, okay, not the old one. And so you'll change one variable from them compared to the new one, okay? So go ahead, finish this off, and then there are some questions on the last slide that you'll be able to work on. Feel free, as always, shoot me an email if you have any questions or any problems. Thanks, guys.